Hello students, welcome to the course on Advanced Digital Communication and the course code is MCE 102. This is the course for MTech EC first semester students. Myself, Dr. Shurajit Bashak, Assistant Professor of EC Department, Guru Nanak Institute of Technology, Kolkata. And this is my official email address. Today we are going to start lecture number 2 from the revision of source coding. In the last class we have discussed about sampling theorem, statement and proof, quantization, and we have also calculated quantization noise. And the topic for today's discussions are principle of pulse code modulation, delta modulation, and adaptive delta modulation. And the lesson objective of this topic is compare the advantages of various pulse modulation techniques and analyze their system performance. And this topic is mapped with CO number 3. So let us start lecture number 2 from the module of revision of source coding with the topic of pulse code modulation or PCM. In PCM, the message signal is sampled and the amplitude of each sample is approximated to the nearest one of a finite set of discrete levels. So PCM basically comprises of two things. One is sampling and other is quantization. So already we knew it. Suppose that this is a message signal xt and it is comprises of a voltage level say minus 4 volt to plus 4 volt. So according to the quantization, first we divide the voltage range into m number of equal voltages like minus 3 volt, minus 2 volt, minus 1 volt, 0, plus 1, plus 2, plus 3 and plus 4 volt. So total divisions are 8. 8 number of voltage divisions are present here. Then at the middle of quantization level, we have considered another level which is called quantization level, which is say minus 3.4 volt, minus 2.4 volt, minus 1.4 volt, minus 0.5 volt, like that, and plus 0.5, 1.5, 2.5, and 3.5 volt. These are the quantization levels. And we assign the code number for each of the quantization level, that is from 0 to 7. Now we are taking the sample. First, do the sampling. So we are taking the sampling at some points. Total we have taken in this picture 1, 2, 3, 4, 5, 6. 6 number of samples. So first is the sample value, natural sample value. So first sample value is just it is between 1 and 1.5 and it is 1.3. Second sample value is 3.6. Third sample value is just between 2 to 2.5, so it is 2.3. Fourth sample value is 0.7, minus 0.7, minus 2.5 and minus 3.4. Now according to the quantization, the sample value should be presented at its nearest quantization level. So its quantized sample value of 1.3 is now 1.5. See, so for 3.6, its nearest quantization level is 3.5. So it is now a 3.5. So for 2.3, its nearest quantized sample value is 2.5. For 0.7, it is now 0.5. Minus for minus 0.7, it is now minus 0.5. And minus 2.4, it is now minus 2.5. And for minus 3.4, it is now minus 3.5. And accordingly, the code number are for 1.5. See, the code number is 5. So assign 5 here. For 3.5, the code number is 7. So assign 7 here. For 2.5, it is 6. For 0.5, it is 4. For minus 0.5, it is 3. Minus 2.5, it is 1. And for minus 3.5, it is 0. So the code numbers belongs to from 0 to 7. So to represent it only in binary form, 3 bits are sufficient. So the 3 bits for 5, we can represent it like a 101. For 7, we can represent it 111. Similarly for 6, 110. For 4, 100. So for 3, it is 011. And for 1, it is 001. And for 0, it is 000. So correspondingly, the electrical signals are for 101 first, 1, 0, and 1. Then it has some gap. That gap is called inter-digit gap. And then again 111. So 3 ones. Then again 110. Some gap. Then again 100. It's like that. So in PCM, this is the coded signal. So in PCM, we need not transmit the total analog signals. Rather, we are taking the sample values and after that finding a coded signal, coded electrical signal using quantization, and we are transmitting just only this last electrical signal. No need to transmit the whole electrical analog signal. So as a result, ultimately noise is very less. Okay. So this is the advantages of using PCM, pulse code modulation. Next is the transmission bandwidth calculation for PCM system. What is the transmission bandwidth? Suppose that V is the number of digits required to represent each quantization level. So in this picture, V is 3 because 3 bits are sufficient. So if V is 3, V is the number of bits for general case. Therefore, what is the number of quantization labels are present? How many number of quantization labels are present? If V is the number of bits or digits required to represent each quantization level, then number of quantization level is Q, say Q equal to 2 to the power V, and obviously number of bits per sample is V, and number of samples per second, that is Fs, sampling frequency, nothing but your sampling frequency Fs. So number of beats per second, you can represent it like that. Number of beats per sample into number of samples per second. So number of beats per second is nothing but your signaling rate R. So R equal to number of bits per sample equal to V into number of samples per second, that is Fs. So R equal to V into Fs. So bandwidth greater than or is equal to half of signaling rate. So V into Fs. So we know that from the sampling theory that Fs should be greater than or is equal to 2 Fm. So 2 to cancel. So the overall bandwidth, transmission bandwidth of a PCM system is greater than or is equal to V into Fm. Now, what is if we increase the number of step size, if we increase the number of voltage levels, then step size is reduced, then your quantization noise is less, but the problem is number V is large, so naturally bandwidth will be higher. So this is the problem of a PCM system. If you want to reduce the quantization noise or quantization error, then naturally bandwidth is increased. Then what is the solution for this problem? The solution is delta modulation. How delta modulation can solve the problem? Delta modulation transmits 1 bit per sample. It doesn't depend on V. It only transmits 1 bit per sample, no matter how many numbers of quantization levels are present. So its bandwidth only Fm, not V. It doesn't depend on V. Here the presence, what is the principle of delta modulation? How it can transmit only 1 bit per sample? 1 bit means either it is 1 or 0. How it can be predicted? So here the present sample value is compared with the previous sample value, and these results whether the amplitude is increased or decreased is transmitted. So if present sample value just compared with the previous sample value, if present sample value is higher than the previous sample value, then binary 1 is transmitted, and if present sample value is lower than the previous sample value, then binary 0 is transmitted. See, the present sample value is higher than the previous sample value, then binary 1, then again, higher. Now here, see, this present sample value is lower than the previous sample value. So binary 0 is transmitted. Again, this case is 0. Okay. Now, transmitter section. Here, XNTS is the present sample value and X cap NTS is the previous sample value. And ENTS is the error signal, which is just the difference between the present sample value and previous sample value. That is XNTS minus X cap NTS. Now after that, this goes to a 1 bit quantizer, and the output of 1 bit quantizer is BNTS. And BNTS equal to delta into sine ENTS. So BNTS equal to plus delta. See, BNTS equal to delta into sine of ENTS. So BNTS equal to plus delta if XNTS, that is the present sample value, is higher than the previous sample value. And if XNTS less than X cap NTS, that is the present sample value, is lower than the previous sample value, then it is minus delta. So if BNTS is plus delta, then binary 1 is transmitted. And if BNTS equal to minus delta, then binary 0 is transmitted. Therefore, UNTS, see, UNTS equal to UN minus 1 TS plus or plus minus delta. So here only either plus delta or minus delta is come, depends on the comparison. So UNTS equal to UN minus 1 TS plus BNTS. So the if the present sample value is compared with the higher than the previous sample value, then one step size plus delta amount step size is increased with the previous sample value. And if it is lower, present sample value is lower than the previous sample value, then minus delta, that is delta amount is decreased with the previous sample value. So this is the principle of delta modulation, where only one bit per sample is transmitted. And this is the receiver circuit, where a accumulator is again required input and it is delayed by TS, and ultimately a low pass filter is present. So this is the receiver. Again, delta modulation have two disadvantages. One is called slope overload distortion and other is called granular noise distortion. So what is slope overload distortion? When the rate of rise of input signal is so high that the staircase signal cannot approximate it, then the step size becomes too small and the step needs too large. Then the errors between the original signal and staircase signal is called slope overload distortion. And similarly for granular noise distortion, when the step size becomes too large as compared to the small variation of the input signal, then the errors between the original signal and the staircase approximated signal is called granular noise. So to overcome these two errors, the step size will be large when the slope of the input signal is high, and the step size will be small when the slope of the input signal is low. That is why adaptive delta modulation comes. Now, what is adaptive delta modulation? So, to remove the slope overload and granular noise, adaptive delta modulation come. Here the step size varies according to the slope of the input signal. If, see, this is the picture. Here the step size is delta, and second case the step size is delta 2. So delta 2 naturally higher than delta 1. This is xt original signal and ut, that is your staircase signal. So with variable step size. So step size now becomes variable depending on the slope of the input signal. So that is why the name comes adaptive. Now how it can be generated? Just simple as that. It is the block diagram is simple like a delta modulation. This part is simple. Just only one is logic for step size control. Here is a logic is written which control the step size. How it can be enlarged or how it can be reduced. What is the amount it required to reduce? Okay, that can be handled using a program which is written here. Similarly, for the receiver part, here also logic for step size control. Okay, so this is all about adaptive delta modulation. So thank you. Let us stop here.